Hello guys, I'm going to go over exercise 9.2a right now, 9.2a. So part A says, this whole problem is asking if this is possible, right? Tastes are homothetic and the own price demand relationship is positive. Alright, let's draw something with homothetic tastes real quick. Let's draw x1, x2. We know with homothetic tastes that we have indifference curves with the same MRS anywhere through that point. Now, let's really quickly imagine that I have this budget constraint and the individual's originally consuming here at point A. Now we want to ask what the own price demand relationship is positive. So let's draw the own price demand curve right underneath. Remember, it has the same axis, so these line up, and that's the own price. So let's go ahead and do a price increase of x1, which will give us something that looks like this for the budget constraint. This is P, this is P prime, where P prime is higher than P. Okay, so you can see that clearly the point C that we end up at has got to be to the left. It's the only way that it can be if this is homothetic. So at the higher price we have C here. At the lower price we have, that was C right here. The higher price we have point A, which is down here. And I have a downward sloping own price demand curve. So clearly that's not possible to have an own price demand curve that's upward sloping according to what we drew. Next, we're going to ask what happens when a good is inferior. So let's real quick redraw something here. Let's draw, okay, imagine we're at point A, and this is P. Now let's go ahead and create P prime, which is higher, okay. And at point P, we are consuming at point A, right here. And so we are asking what happens when the good is inferior. Well, in order to do that, I have to disaggregate the substitution effect. So let's figure out where the substitution effect would be. Let's compensate this so it's right about here or so. And then moving from A to point B is the substitution effect. Now, however, I need to have a inferior good. So the question asks, how do I get an inferior good? Well, as I take the income away from this person, they actually consume more of the good. So that means point C's got to be here somewhere. So let's draw that down, point C. And as you can see from that, I actually do have an own price demand relationship that is negative. So it's totally possible. Note that if I had made C, well, it's kind of difficult with this the way it's drawn, but if I had made C be on the other side of A, maybe I relax this budget constraint a little bit, I could have an own price demand curve that slopes upwards too. So being inferior could be up or down when the the income effect is so much bigger than the substitution effect. Remember, that's called a Giffen good. A Giffen good is technically inferior. All right. Next, we need to do a model with endogenous income for the next two, okay? So let's do that. So we have a model with endogenous income. A good is normal and its own price-demand relationship is negative. So endogenous income, let's suppose that I have all other goods and I have some endowment here, and this is P. This is P prime. Whoops, let's put P under here so you can see that. All right, that's price P. That's price P prime. And originally, we are at point A down here somewhere. Okay, let's go ahead and disaggregate the substitution effect. So I have to uncompensate this person. So let's say that the movement from A to B is the substitution effect here. Now, we see that the good is normal. So, a good that's normal means that point C, when I give the person their income back, point C is going to have to be to the right of B. So point C could be right here. Right, so at the higher price, we have point C. At the lower price, we have point A. And I have a downward sloping ohm-price relationship. So that's completely possible. Part D actually asks, in a model with endogenous income, a good is normal, its own price demand relationship is positive. Can I somehow make this positive? Well, yeah, I sure can. If I take point C and instead move it to be right here somewhere. Okay, so you see this gigantic income effect, or wealth effect, excuse me. Then I can get C over here, and I can have an upward sloping ohm price demand curve. So either is possible. Okay, on to part B. So this is 9.2, part B. The first part of B says that we have taste represented by Cobb-Douglas utility function, x1 to the alpha, x2 to the 1 minus alpha. Find some demand functions. So we do the typical maximizing over x1 and x2, some utility, which is equal to x1 to the alpha, x2 to the 1 minus alpha, subject to p1x1 plus p2x2 is equal to income. We can easily set the MRS equal to p1 over p2 in this case. This implies that, what's the MRS here? Partial u with respect to x1 over partial u with respect to x2. So partial u with respect to x1 is going to be alpha x1 to the alpha minus 1, x2 to the 1 minus alpha over partial u with respect to x2. That's the new denominator of the MRS, so I'm going to have 1 minus alpha, x1 to the alpha, x2 to the negative alpha. And we'll set that equal to p1 over p2. Okay, this implies that alpha over 1 minus alpha, I just separated this term out. Alpha, x1 to the alpha minus 1, that's actually a negative number, so if I move it down here, this becomes x1 to the negative alpha plus 1, so I have a negative alpha plus alpha, those cancel out, so I have x1 to the first power. Here, x2, I bring this up to the top, x2, that's positive, or it's negative here, I bring it up as positive, so I'm 1 minus alpha plus alpha, I have plain old x2 is equal to p1 over p2. Let's solve this out for one of the goods. Let's do it for x2. x2 is equal to, I have p1 over p2. I'm going to multiply both sides by x1. And then I'm going to multiply by 1 minus alpha and divide by alpha. Or multiply by the reciprocal of that. Okay, now I have to plug into the budget constraint because this has x2 and x1, two endogenous variables. So this implies that p1 x1 plus p2 x2, let's do this, p1 x1 over p2 times 1 minus alpha over alpha. Okay, the p2's cancel, is equal to income. This implies that, look, I have p1 x1, I have p1 x1 times 1 minus alpha over alpha. So if I factor this out, I have p1 x1 times 1 plus 1 minus alpha over alpha is equal to income. Let me make sure I did that right. Okay, looks good to me. Let's add this to both sides. This is going to be alpha over alpha. So I have alpha plus 1 minus alpha, so it's just 1 over alpha. So I have, implies that p1 x1 times 1 over alpha is equal to income. Let's solve this out for x1, whoops, not x2. x1 is equal to, divide both sides by p1, alpha income over p1. Okay, We've seen this before, so I'm going to go ahead and jump ahead. We know that x2, it's exactly symmetric. Instead of wanting alpha amount of it, you're going to want 1 minus alpha income divided by P2. Okay, so these are your demand curves, demand functions. Now, we want to know, it says, verify that the own price demand curve slopes downward. So one, I think, easy way to do it is just say, hey, what happens to x1, right? So an own price demand curve is graphed in P1 and x1. What happens to x1 as P1 changes? In other words, let's take the derivative of x1 with respect to P1. So we'll take the derivative of x1 with respect to P1. What does that equal to? Well, remember, this P1 on the bottom is actually P1 to the negative 1. So if I imagine this is P1 to the negative 1, I bring down the negative sign. So I'll have negative alpha income over P1 squared. That's negative, so you can see as P1 goes up, x1 goes down. As P1 goes up, x1 goes down. What I'm doing is I'm talking about a downward sloping curve right there. Let's do the same for x2. Partial x2 with respect to P2. Same thing here. It's a negative because it's P2 is to the negative 1 if I bring it up here. So bring the negative sign down. Negative 1 minus alpha income to the P2 to the negative 2. Well, that's the same thing as putting P2 squared on the bottom. This is also negative. We are talking about a negative slope. The other way to do this might be a little bit more comfortable for those of you who like to think of things graphically. Let's just invert this to solve out for P1. So if I solve this out for P1, I have P1 is equal to, this is easy, I can just flip x1 and P1's locations. Alpha income over x1, P2 is equal to 1 minus alpha income over x2. So you can see that this is actually downward sloping. As x1 goes up, P1 goes down. As x1 goes up, P1 goes down. That's a negative relationship. That is negatively sloped. So if you graph this on Wolfram alpha, you'll also get a negative slope. Okay. Finally, part B, not finally, but part B says, suppose that all income is derived from an endowment. If E2 equals 0, what is the shape of the own price demand curve for x1? Okay, so this actually, I could plug in the value of the endowment right here instead of income, right? So what would be the value? Let's write that down. It would just be P1 P1E1, because that's how much of the endowment we have. P1E1. It would be plus P2E2, except for I don't have any E2, so it's just P1E1. Basically what I can do is here, I can just replace this for alpha P1E1, 1 minus alpha P1E1. You see the P1s cancel there. Okay. And so the question now, we see x1 is equal to alpha E1. What happens to the own price demand curve? Okay, and so the own price demand curve is absolutely vertical because P1 actually doesn't end up showing up in here. Finally, part C asks us, oh, well, what happens when there is an E2? So I can replace this with P1E1 plus P2E2. That's a little messy, sorry. P1E1 plus P2E2. Okay? And you can see that if you were to take the derivative with respect to P1, okay, here you have, let's write this out, x1 is equal to alpha P1E1 over P1 plus alpha P2E2 over P1. So, okay, let's go ahead and cancel those out. So my demand for x1 is alpha E1 plus alpha P2E2 over P1. Well, you can see when you take the derivative of this now with respect to P1, there is a P1 there, and this is P1 to the negative 1. And so your derivative is going to be, well, the derivative of this part is 0. And your derivative, when I take the derivative of x1 with respect to p1, it's going to be minus alpha p2 e2 over p1 squared. So you can see that that is negative. As we discussed before, negative derivative means a downward sloping own price demand.